This is section 3.5, implicit differentiation. This section introduces a new method of differentiation which says that we should differentiate implicitly both sides of the equation and then we solve for y prime. Let's have a look at this example. So in part A, we are given a circle equation, x squared plus y squared equals 25, and we should get dy over dx, which is y prime. Let's start with differentiating both sides implicitly with respect to x. So this will be 2x plus 2y y prime equals to 0. Now we want to solve for y prime. Basically, if we divide both sides by 2, this is what we get. X plus y prime is equal to 0. And if we take x to the other side, this will become y prime equal to negative x. Now dividing both sides by y, so I can get y prime alone. This is what we will get. So y prime is equal to negative x over y. In part B, we have to find an equation of the tangent line to this circle at the point 3, 4. So basically we found y prime. Now we have to find it at the point 3, 4. Recall that the equation of the tangent line looks like this: y minus f at point we have here, x is going to be 3 at f3 equals to f prime at 3 multiplied by x minus 3. Now we found f prime, so this is f prime at x. Now if we want to find f prime at 3, we just have to substitute using this expression. So this will be negative 3 over 4 using the point, the given point. Now f at 3 is going to be 4 as indicated in the point. Now to put things down, this is what we will get. Y is equal to negative 3 over 4 multiplied by x minus 3 plus 4. If we want to distribute, this is what we will get: negative 3 over 4x plus 9 over 4 plus 4, and adding these will give us 25 over 4. So this will become negative 3 over 4x plus 25 over 4. And this is the equation of our tangent line. Let's have a look at another example. In part A, we have to find y prime given this expression: x cubed plus y cubed equals to 6xy. So to use the implicit differentiation, we should differentiate both sides implicitly and then solve for y prime. So we are differentiating with respect to x. This will give us 3x squared and plus 3y squared multiplied by y prime equals, here we have 6 multiplied by the product rule, because here we're differentiating with respect to x implicitly. So the derivative of x is going to be 1, the derivative of y is going to be y prime. Now using the product rule, we will be multiplying 1 times y is going to be y plus x times y prime, and this is what we will get. Now if we distribute 6 by y and then we multiply it by xy prime, this is what we will get. This side will stay the same: 3x squared plus 3y squared y prime equals to 6y plus 6xy prime. Now basically we want to solve for y prime. That's why we should get these y prime values in one side of the equation and everything else on the other side of the equation. If we take 6xy prime to the other side, this is what we will get: 3y squared y prime minus 6xy prime, and this I will take it to the other side, so this will be 6y minus 3x squared. Taking y prime as a common factor, we will be left with a 3y squared minus 6x, and outside we have 6y minus 3x squared. To have y prime alone, we have to divide both sides by this expression: 3y squared minus 6x over 3y squared minus 6x. If we look closely at this expression, we can take a 3 out from the numerator and the denominator as a common factor. So this can look like this: 3 out, and then we will be left with 2y minus x squared. And as for the denominator, we can take 3 as well. This will be y squared minus 2x, and we can take 3 out. This is the expression we get for y prime. And then in part B, we have to find the tangent to the volume of this cart's x cubed plus y cubed. So this is the equation at the point 3, 3. Now we know if we want to find the tangent of any line, then what we are supposed to do is to find f prime at that point. So we have to find f prime at the 3. We already found this f prime at x. Now, so for part B, let us first write our equation of tangent line. This will be y minus f at 3 equals to f prime at 3 multiplied by x minus 3, since our x is a 3. So at the point 3, 3. Now we found f prime x. Now we have to find f prime at 3, knowing that our y is 3 as well. So we will use this equation we found here, which is 2y minus x squared over y squared minus 2x. So this will be 2 times the 3 minus the 3 squared over, where we have 3 squared minus 2 times 3. And this will be here 6 minus 9 over 9 minus 6. And this will be negative 3 over 3, which is negative 1. So the tangent line equation will be y equals to negative 1 multiplied by x minus a 3, and f at a 3 is going to be this y given, which is plus a 3. So if we take it to the other side, this will be plus a 3, and this can be written as negative x plus a 3 and plus a 3. So this is 6 minus x. Now for part C, we have to find a point in the first quadrant where the tangent line is horizontal. So we found here the tangent line equation, and if we want the tangent line to be horizontal, it means we should set y prime to be equal to 0. We found earlier our y prime, it was 2y minus x squared over y squared minus 2x, and if we want this to be equal to 0, then 2y minus x squared should be equal to 0, where the denominator, which is y squared minus 2x, should not be equal to 0. If we solve for y in this expression, we'll get y equal, if we take x squared to the other side, this will be x squared over 2. So we can write y in terms of x, and then we use our original curve, which is x cubed plus y cubed, which equal to 6x multiplied by y. So here we have x cubed plus y cubed equals to 6xy. And in this equation, we will replace every y by x squared over 2. So this will become x cubed plus x squared over 2 power 3 equal to 6x multiplied by x squared over 2. Now here we can do some simplifications. This will become x cubed plus, we know x squared power 3 is going to be x power 6 over 8. 2 power 3 is 8. And here 6 over 2 is 3. So this will be 3x cubed, because here we have an x and here we have an x. Now if I take this 3x cubed to the other side, and we take x power 6 to this side, this is what we will get. X cubed minus 3x cubed equals to negative x power 6 over 8. So this will become negative 2x cubed equals to negative x power 6 over 8. Now if we divide both sides by negative 1, this is what we will get. We'll get 2x cubed equals to x power 6 over 8. Now since we want to solve for x cubed, we can divide both sides by the less power, which is cube. So here we can divide by x power 3, and here we can divide by x power 3. What we will get is 2 equals to x power 3 over 8, because x power 6 and x power 3, this will give us only x power 3. And if I take a to the other side, x cubed will be equal to 16. Now taking the third root of both sides, we will get the third root of 16, or we can write it in another way, 2 power 4 over 3, because 2 power 4 is 16, and this is the third root means 1 over 3, so we can write it in this way. And as we have found earlier, y equals to x squared over 2, then replacing by this expression, we have 2 power 4 over 3 power 2 over 2. This will give us 2 power 5 over 3. And basically the tangent is horizontal at this point, so the point that we found is 2 power 4 over 3, 2 power 5 over 3. So this is the x and this is the y, where we get the tangent horizontal. Let's have a look at this example. We have to find y prime given this function. So starting from this side, if we want to differentiate, we have to use the chain rule method as we have done earlier in this chapter. So we should find the derivative of the angle first. So here it will be 1 plus y prime, because we're differentiating with respect to x, multiplied by cosine of the same x plus y. On the other hand, we can see that we have a product rule here. So y squared, the derivative of it is going to be 2y y prime, and the derivative of cosine of x is going to be negative sine of x. Using the product rule, we have to multiply 2y y prime by cosine of x minus sine of x multiplied by y squared. And this sign, this negative sign is coming from the negative sign, which is the derivative of cosine of x. So solving for y prime, we might firstly distribute cosine x plus y for 1 and y prime, and this is what we will get. Cosine x plus y plus y prime cosine of x plus y equals to 2y y prime cosine of x minus sine of x multiplied by y squared. Now basically, if we want to solve for y prime, we might take this to this side and take cosine x plus y to the other side. This will give us y prime cosine of x plus y. This will stay in its place, and taking this to the other side will give us negative 2y y prime cosine of x, and on the other hand we have negative y squared sine of x minus cosine of x plus y. I just took y squared here. Now solving for y prime, we can take it as a common factor. This will be y prime multiplied by cosine of x plus y minus 2y cosine of x, and on the other hand we have negative y squared sine of x minus cosine of x plus y. If we want to solve for y prime, we might divide both sides by this expression, cosine of x plus y minus 2y cosine x, and here it will be cosine of x plus y minus 2y cosine of x. If we take as a common factor in the numerator and the denominator a negative sign and removing them, this is what we will get. Y prime equals to negative 1 multiplied by this expression in the numerator, which is y squared sine of x plus cosine of x plus y, over, if we take the negative sign outside, this will become 2y cosine of x minus cosine of x plus y, and this of course is multiplied by negative 1, and this can be cancelled with this. This is the expression we got for y prime.